Okay, now let's say we got our state space equation of a system that has the following matrix. Now we need to find out if we are able to observe the system and if we are able to control the system. Now the example is the similar one I gave you like earlier. For example, if there's a car you're driving now and you are in control of steering wheel. Now you can turn the steering wheel left and right and the car will go left and right, but only car, there are two things. One is constant, which is the mass of the car, and the other is a velocity or acceleration of the car, which is more or less. And that function will define the momentum of the car. Now if the car is going too slow or is going slow, what you can do is you can actually turn the car left and right with ease with the steering wheel. But if the car is going fast, there is a function of momentum, which is mass times the velocity. And the car, you might try to turn the car, but momentum will resist it, and the car might not turn as quickly, or it might overturn. So it's similar to any system you design. There is a MATLAB later on. If you want to do master's degree, there is a thing called MATLAB, and they actually teach you how to design a state symbol equations using the matrices. In a very big space state equation. So we will have a look at that one. Now observability is denoted by an OT, observability matrix, and controlability, I'm just going to do CT matrices. Now what we do is, how do we figure this one out? Let's go to the next slide. Now the matrices are given, let's say, so let's say the matrices A is given, the matrix B is given, and the matrix C is given. So we got the A, B, and C matrix. Now, first we need to find the controllability. The controllability matrix is given by this matrix, which is B, A, B. What is B? What is A, B? Now, the matrix B is the one that's given to you already in the previous slide. B is 1, 1. Now AB is unknown. We don't know what AB is, but that's the A and that's the B. So A is this and the B is this, and I can multiply. First I need to find out if I can multiply. So it's 2 cross 2, and that is 2 cross 1. So yes, I can multiply, and the answer will be 2 rows 1 column. Yeah. So when you multiply, it's 1 times 1, which is minus 1, and 1 times 1, which is a plus 1 here. Then you do 2 times 1, which is a 2, plus minus 3 times 1, which is minus 3. So minus 3. Yeah. So 1, that is the top one. 1 minus 1 plus 1 is 0, and 2 minus 3 is minus 1. Yeah. So now you got the AB. Once you got the AB, you need to put in here. So instead of B, you put 1, 1. Instead of AB, you put 0, minus 1. Now, I still don't know if the system is controllable or not. So what I am going to do is, I'm going to find the determinant of that CT, controllability matrix. To find the determinant of that one, I'm just going to do that in a minute. So I need to find out the determinant of this matrix. So I need to find the determinant. It's a 2 by 2. So I'll multiply this by that. So that is a minus 1 plus 1 times 0 is a 0. So determinant is minus 1. Now the determinant of this matrix is a non-zero. So if the determinant is non-zero, so it's controllable. The system is controllable. Now I want to find out the observability is a tongue twister for me. Yeah. Observability of the system. Now the equation, the matrix for observability is given by OT C CA. I know what C is because the C matrix was 2, 3 if you remember from the first slide. Okay, so I got the C matrix, but I don't know what CA is, but I know C and I know A, so I can multiply them. So C is 2, 3 and the A is minus 1, 1, 2, 3. Where I got this one? From the first question. Then I multiply. Before I multiply, I need to see how many rows are there. 1 row, 2 columns, and that's 2 rows, 2 columns. So yeah, 2 cross 2, I can multiply them. Yeah, but the answer will be 1 row, 2 column. Yeah. Okay. So when you multiply, this is how you multiply. 2 times 1, which is minus 2, and 3 times 2, which is 6. So that will give me a number. Minus 2 plus 6 will give me a 4. Then the second one, I need to do that one again. This thing with that one. 2 times 1. Oops. Oh, it can write as well. Okay. 2 times 1, which is 2. And 3 times minus 3, which is minus 9. And this will give me 7. Yeah? Okay. Minus 7. Now I need to put that into this equation. What was C? C was 2, 3. So I put here from the first slide, C is 2, 3. So I put 2, 3 here. Now then there's a CA. What's CA? CA is 4 minus 7. And I put 4 minus 7 here. I need to find if this system can be observed or not. So I need to find the determinant of the system. So we need to find the determinant of this system, this matrix OT, observability matrix. So minus 7 times 2, which is going to give you minus 14, minus 4 times 3, which is 12. What is the answer?
Minus 26.
Minus 26. Now, it is not equal to 0, so it means,
It's observable.
yeah. So we can observe the system and we can control the system. Sometime in